mankind is facing many pressing issues, but the most urgent threat is climate change. Climate change caused by global warming is real and happening right now, evident by the two hottest years of our recorded history in 2014 and 2015. My research tries to reduce climate change by recycling CO2 back into fuels. But how are we doing this? We are working with an enzyme called nitrogenase, shown in the center of this slide. And the Rebelein lab at UCI could recently show that this enzyme can catalyze a very unique reaction, the conversion of the toxic exhaust, CO, into propane. I was able to demonstrate that the isolated and purified enzyme alone can also use the greenhouse gas, CO2, and convert it into propane 2, also known as propane autogas, the third most common automotive fuel. We wanted to bring these discoveries to an application, but in order to do so, we had to overcome several hurdles. The biggest obstacle was the scalability of this process, since the assays I run in lab are rather small, as you can see here. To overcome these limitations, we were wondering, can we maybe use whole bacterial cells, which naturally contain already nitrogenase? And maybe these bacteria, called Azotobacter vinelandi, can also in vivo within the cell convert CO2 and CO into fuels. Indeed, we were able to design genetically engineered versions of this bacterium which exactly do this. At the moment, we are developing a two-step biofuel process based on these genetically designed bacteria, which first converts CO2 into CO, shown on the left, and subsequently a second design strain converts CO into propane autogas, shown on the right. I'm convinced that the technology we are developing will be among the solutions to reduce climate change by recycling CO2. The production of green renewable autogas by nitrogenase creates an artificial fuel cycle with net zero CO2 emission, helping us to fight global warming and while providing at the same time a sustainable energy source for traffic and industries. Thank you.
Awesome, awesome. Tell us a little bit about how you got into this project and how do you think this gets out of the lab?
Okay. So the funny thing is, so you talked a lot about nitrogen at the beginning, and the enzyme, as you might have noticed, is nitrogenase. So that's the natural way how this nitrogen is converted into ammonia and made bioavailable. So that's the counterpart to the Haber-Bosch process. And that's how it all started out. And the fantastic thing, the chemistry happens in one of the metal clusters inside the enzyme. And we are really interested in this, and I love that we're getting closer and closer on an atomic or even electronic basic to understand how the Haber-Bosch reaction happens and how this happens, which is still not really understood today. So that's how it started and how it's taking off. So basically, through these projects, we have at the moment 3 patent applications basically, and we are trying really to get money for a startup company and get it all out and really try to scale it up in fermenters, containing hundreds of liters and see what happens.
Awesome, awesome, wonderful. Great job.
Thank you.